Mr. Chairman, Dr. Tobisky, you mentioned a Carrington-class storm. What is that, and how frequently do they occur?
Great question. They occur infrequently. First of all, the name comes from an 1859 event that Dr. Gibson mentioned, where they observed it from the ground. They saw big streamers coming off the sun when the clouds were there in London. That event caused aurora over Cuba. It caused balls of fire going down telegraph lines in the Midwest, and it also caused, I think, a fire in a telegraph station in Madison Square Garden or in New York City. So this is where there's huge geomagnetic currents set up in the Earth's crust. Those currents got to go somewhere, and they follow the path of least resistance. So they go down power lines, they go down oil pipelines, wherever they can go, they'll travel. So that's kind of what a Carrington-class event is. The occurrence rate are very infrequent, although we had an event in July of 2012 where had the event occurred about 4 days later when that region on the sun was facing us, we would have had an extremely large geomagnetic event. Maybe not a Carrington, but certainly like a G4 level, it'd be like a G4 hurricane. However, it was on the side of the sun. The sun had rotated around, and we just missed that one. So those happen maybe on the order of once every solar cycle or every 10 or 12 years. There's probably moderate-sized storms that happen every year, but that's kind of the frequency of those.
Was the 1989 Hydro-Quebec power collapse caused by a Carrington-class storm?
No, it wasn't. It was a smaller storm than the Carrington event, but it just happens that the ground conductivity in that part of the North America is very susceptible to strong currents, and the Hydro-Quebec power grid was not able to trigger off its transmission lines quickly enough.
And how long was there a power collapse in the 1989 Hydro-Quebec?
In that one, it was for a few hours to a few days in that region, yeah.
Dr. Spahn, in your written testimony, you state, for example, the electric power industry is susceptible to geomagnetically induced currents which can overload unprotected power grids and result in widespread power outages. What has to be done to protect power grids?
Well, I think there are kind of two things that need to look at. One is providing the early warning to those power grids so that they can, and I'm not a power grid operator or an expert necessarily in this field, but they can reroute power in ways that the predicted induced currents on their power lines would not damage their transformers, which, as Dr. Tobisky mentioned, that is kind of the failure mode there. So kind of reservicing how they route their power is one way, but that requires some predictive capability. And so, again, trying to understand how this works and providing that information through the operational agency so that they can provide that information down to the power companies I think, is the way to prevent that sort of occurrence.
Well, I thought when you began, you said two ways. So we've got early warning. Is there a second thing that can be done to protect the power grid?
Yeah, well, the early warning is kind of the initial step. The second step is that the power grids need to develop a system, and perhaps they already do, where they can reroute their power so that it avoids areas that we think are going to have large currents being induced. So that would be the second.
Any judgment on how much cost is necessary in order to provide that kind of early warning with the accuracy and precision that is necessary for the power distributors to be able to properly react and plan and minimize damage?
I'm not that's not something that I'm able to provide. I think there may be other people on the panel that could provide, but I would not know what that is.
Well, my time has expired, but if anyone has a quick answer, the chairman might indulge us on how much the cost might be.
I'll make an answer, which is that it's not a quick answer, because it's a complicated problem. To do what you just asked for, which is to get accurate forecasts of how bad the geomagnetic activity is, we don't have that answer yet, and there is no one single thing that could be done that would do that. So it would be hard to answer that question.
All right, thank you, Mr. Chairman.